This video will demonstrate how to make an expression with an operator, unary, binary, or ternary. And before we start, we have to realize that we have to answer some questions when we do this. When you have an operator, it will return a type and a value category. Value category is L value, R value, or neither. An operator imposes obligations on its formal parameters, and then when you supply operands, they supply actual types and value categories. So the question is the actual type and value category implicitly convertible to the formal type and value category? Another question is, does the operator have a side effect? Even if the operator itself doesn't, it does if one of its operands has a side effect. So these questions will need to be answered. Let's go to the Semel Editor in any context in which you need to make an expression. You can make a new binary, ternary, or unary. There's no reason to pick any one of these. Everything in this video applies equally to all three. I'm just going to pick binary. When you make a new operator expression, you have yet to choose an operator and yet to choose its operands. The FYI reminds you that you're missing an operator. Let's choose, and again for no particular reason, plus binary. There's also a plus unary, but that's not going to show up here in this list because this is for binary. When you make that choice, it appears here in the right, and the FYI goes away. But there's a new FYI that says you have not yet chosen a function overload. We'll come back to that. Let's make operand 0 be the integer 1. So I can paste that from the clipboard of commonly available expressions. So here is 1, and it is an R value of type int. Navigate up to my owner. Let's go to operand 1, the second operand, and make a new expression temporary whose type is std string, which is also available from the clipboard. So here's the type. The owner says I am a temporary expression, I am default initialized, and if you navigate to the owner, it says, okay, you have your expression. You still haven't chosen a function overload, and you think to yourself, well, I don't have to do that. When I save the Semels, export the code, and compile the code, the compiler will choose an overload for me. Of course, there is no overload of plus that takes an int and a string. So you will get an error message. Also notice that because there is no function overload, we don't know the return type of this expression, we don't know the return value category, and we don't know whether it does or does not have a side effect. If you scroll down to the synthesized associations, you can learn here there is no exact match and there are no viable matches. So you don't have to save your Semels, export your code, and compile your code only then to get an error message. You can get the indication that it won't compile right here within the Semel Editor. Now, because there is no such overload, if I say change this, there are 76 candidates, but none of them are correct for int and string. Okay, well, let's try something else. Let's make a literal double quote, whose type is not std string, it's array of 0 const char in L value context. Navigate up to your owner, and that looks like it should compile. Again, there's no exact match and no viable matches. Why are there no viable matches? Isn't double quote going to turn into something that can be plussed with a string? Well, let's take a look at our choices. If you scroll down, you'll see that this choice takes a pointer to a const. That's a template formal parameter. It could be const char star, and then the const array will become a const pointer, so there is an implicit conversion. The only reason that that didn't show up as a viable match is because we don't know what char t is, and neither does the Semel editor. But if you choose that, notice that the error message that FYI went away. You said I want that overload, and this array of const char becomes a pointer to a const char which satisfies this function overload. Plus we know what the return type is, what the return value category is, and we don't know whether this has a side effect because we don't know if that constructor has a side effect or not. That concludes this video. Thanks for watching.